everyone, today we are going to deal with the star to delta transformation. I hope you have gone through our previous video in which we had derived delta to star transformation, because if you haven't, it might be a bit confusing for you, and we are going to use the concept from the previous video. That's why it's important to go through that video. So before starting the video, we have to remember that if you want to convert any delta into a star, the formula will be, now if you have gone through, you can revise that with me. R1 will be the register in between. I have shown you how to draw a star within a delta. Okay, so that's how we draw a star connection. Okay, for if this value is R1, R2, R3, we have already derived the formula, so we are using the previous formula in which we find that R1 will be this resistance, and we will have the product of 2. That's why R12 times R31 upon sum of all the resistors. So we'll write this formula again. If you have observed this formula keenly, you will see that the denominator of all the resistors, denominators of all the value are same, and in the numerator we are just changing the products. Now once you have written all this formula, our next task is to find. Now let's find R1 times R2 plus R2 times R3 plus R3 times R1. Okay, now let's find the product. Okay, if we will find the product, the denominator, since the denominators are same, so we will have R12 plus R23 plus R31 square. Okay, whole square, because if R1 and R2 will multiply together, the denominators are same, that's why they will in the form of a square. And for numerator we have to write R12 square times R31 times R32. Similarly write all of them. It's just basic multiplication. Okay, so don't get confused with it. After writing this, all you have to extract the common. Okay, so R12, R23 and R31 is common. After taking the common, we find that R12 will remain, okay, from this, and here R23 will remain, and in this section you will find R31. Okay, in denominator we are already having R12, R23 and R31 in square root form. Okay, square form, so this will cancel out and the remaining will be
R23 is given by
R12,
this formula.
R23, R31, R12 plus R23 plus R31 with R1, R2 plus R2, R3 plus R3, R1. Okay, so this one will be remaining. And if you have remembered the problem which we have written previously, these relations, okay, you can see that you can derive these in all three forms. Initially, if you will write R1 is equals to, what is the formula for R1? R1 is equals to R12 times R31 upon sum of all resistors. Okay, R12 plus R23 plus R31. You can replace these and whole denominator. Okay, these two things with the R1. If you will write R1 and if you will replace all these by R1, it will be R1 times value. Similarly, if you will substitute the value of R2 here, okay, which is R12 times R23 upon sum of R12 plus R23 plus R31, you will get from this. Okay, you will have to replace these complete by R2. Okay, if you will do so, you will find the value of R13. Okay, R13 times R2 will give you R1 times R2 plus R2 R3 plus R3 R1. Now if you give the value, you will find R1 plus R3 plus R3 R1 times 2 in this case. Okay, now again in the value, if you will use these and these for the, if you will substitute the value of R3, okay, we know that R3 is equals to R12 times, sorry, R13 times R23 upon R12 plus R23 plus R31. Okay, now let's substitute the value. Now you will get R12 is equals to R1 times R2 plus R2, R3 plus R3, R1 upon R3, which will give you R1, R2 by R3 plus R2 plus R1. Okay, so that's how you can identify the formula which will help you to convert the star connection into a delta connection. So if you will substitute the value, if you are drawing the resistor in the outermost circuit like this, now you can easily find the value of this R12, which is given by the formula using this and this. Okay, now similarly if you use R23, these two resistors will be used. Similarly R31. Okay, and if you want to remember it easily, now to remember, if you are thinking how to remember, the equivalent delta resistance between any two terminals is given by the sum of star resistor between those terminals plus product of these two resistors divided by the third star resistance. While listening it might sound complicated, so I will demonstrate you again. If you have to find the value of R12, okay, to find R12, in this case, in star to delta transformation, the numerator will remain same. Okay, so numerator means product of these two plus these two plus these two will remain same. So write the sum of star resistance between those terminals plus product of these two stars. Okay, now let's provide the R1 into R2. This is the product between these two resistors. Now plus again these two resistors means R2 plus, sorry, R2 R3 plus R3 R1. Once you have done this, now you have to identify the denominator for denominator, since 1 and 2 exists between the terminal 1 and 2, so the resistor which is not connected to them is the R3, so divide by R3. Similarly R23, for R23 the numerator will same as mentioned earlier, R2 R3 plus R3 R1. Again you are looking for the resistor between 2 and 3. The resistor which is not involved is R1. That's why it will be R1. Similarly, R31. For R31, again the numerator will same. R12 plus R2, R3 plus R3, R1 upon the remaining one is, you have resistor over here, so remaining one is this. So we'll write R2. So that's how you can find the resistors from, if you are provided with a star connection and you want to convert in delta, it can be done easily. And hope this trick is helpful for you. If you are looking for such more insightful videos, do mention in our comment section, and like, share, subscribe. Blessy being. Thank you.